Happy Monday or Tuesday. Today, in this video, we're going to have a brief introduction to statistics. Some of this stuff you've seen before, and some of it you have not. Some of it will be review, some of it will be new. So first, we're going to take a look at some definitions, some basic definitions of statistics. So we have the mean, which is also known as the average. And the mean is the average of the numbers that you have in your set. You take all your numbers and add them up and divide by the total number of numbers that you have. I'm sure you have seen mean or average before. Then we have median, and median is the number in the middle. So when you're trying to find the median, you order the numbers from greatest to least and count to find the number that's in the middle of the set. And we'll see an example of this. And then mode. Mode is the number that appears most often in the set. Usually these three are the ones that you've been exposed to, and this one is usually for a high school statistics class. And standard deviation, it's a calculation, which we're going to see in a few seconds, that shows how much variation or how much difference there is in the set from the mean. So a set of data that has a wide distribution, so has numbers that are high, numbers that are low, numbers that are in the middle, will have a larger standard deviation than, say, all the numbers that are very close together. So an example of something that probably has a really large standard deviation in the United States, for example, is average income salary. We have some people in the United States that are making millions of dollars, and then others who are not making anything. Something that probably has a small standard deviation is height. So the ranges of people's heights in the United States are, they're from maybe there are a few people that are 7 feet, to most people which are between 4 and 7 feet. The range isn't that big there. So those type of distributions have smaller standard deviations. So here, let's say this is my six people in my class. Obviously the class is not AP Bio, given the scores on the test. It's some small class with 6 people. And I'm going to find the mean, median, mode, and standard deviation for this data set. So for mean, the first thing you do for mean is add up all the numbers. So I have my calculator out, and I'm going to add up all the numbers. 99 plus 88 plus 52. Sorry, I typed in the wrong number. Plus 81 plus 98 plus 98 is 516. So this adds up to 516. And then I'm going to divide this number by the total number of scores. So there are 6 scores. And you get 86. So the mean, this is the mean. Okay. Now for the mode, which is easy, well, this one in red. Mode is a number that appears most often. You'll see here 98 appears twice and all the other numbers appear once. So the mode is 98. There can be distributions that have no mode or 2 modes. Sometimes there are distributions that are bimodal, meaning they have 2 numbers that appear most often. And there are some distributions that have no mode. All the scores or all the data points appear only once. Now for the median, we have to rearrange numbers in order from greatest to least. So we have 99, not 98. So 99, then 2 98s. Whoever got that 99. So we got 98. What's next? 88. Then 81. And then last but not least, some lame person who didn't study and got a 52. So the middle number, it would be here, in between 98 and 88. So 1, 2, 3, and then the sort of 3 of the numbers are on this side, and 3 of the numbers are on this side. So the middle number would be here. So since there's no middle number, what you do is you average these two together to find the median. So if I average those two together, you would do 98 plus 88, and then divide by 2, and you would get 93. So the median in this case is 93. Median. Okay. Now, if you have an odd number of points, you'll have a median number, and you won't have to take the average. So, for example, if you had the data set of 1, 2, 3, 4, 5, someone did really bad on the test, The median number here would be 3, because that's in the middle. This is an odd number. When there's an even number of numbers, you have to take the average. Now, standard deviation is a little bit more complex to calculate, so I give it its own slide. The number set I put down here for us, so that we have it. So this is the formula, and I actually took this straight from the AP Biology formula sheet. So what this says to do is, it says standard deviation is equal to the sum of, okay, the one data point minus the mean squared. And you do that for all the data points and add it up. Then you divide by the number of numbers minus 1. So you divide this, the sum of all the numbers here, divided by the n minus 1. So in our case, we have 6 total numbers, and we minus 1, so we divide it by 5. And then you take the square root of it. And that gives you your standard deviation. So we're going to calculate it for our set of numbers. So the first number that we have is 99. And we're going to subtract the mean, which if we go back, I believe was 86. 86. And then we're going to square it. So 99 minus 86 squared is 169. Okay, we'll do our next data set. Is 88. This feels like a lot like chi-square, actually. Minus 86 squared, which is what I can do in my head. 8 minus 86 is 2, and 2 squared is 4. That one was easy. It should be 89. 6. Oh well. Alright, and then the next one is 52. This one's going to be larger. 52 minus 86 squared. So 52 minus 86 squared. 1,156. Okay. Next we have 81 minus 86 squared. So that's that one I can do in my head too. So that's 5, and then you get 25. Okay. 2 more left. So we have 98 minus 86 squared. So this one I can also do in my head. 98 minus 86 is 12, and 12 squared is 144. And what made it easier is that there's 2 98s, so I don't have to do the next method. We're just going to get another 144. So then what I'm going to do is I'm going to add all those up. So 169 plus 4 plus 1056 plus 25 plus 144 plus 144 is 1642. And I'm going to divide it by n minus the number of numbers. We have 6 numbers minus 1, so we're going to divide it by 4. And we get 410.5. And then what we're going to do, what the formula says to do, is square root it. So I'm going to square root. And we get 20.26. So actually, because I'm lame, I actually made a mistake, and some of you are like, stop, probably in the video, let's erase. Our number is not, a number of numbers that we have is 5, not 6. I'm lame. So we're going to put a 6 here. I'm sorry, 5 here. God. Okay, because we had 6 minus 1, I did it already. And so the numbers is going to change. So that is, I'm sorry, I'm lame. 328, 4. And divide, and I'm going to square root this. Sorry, guys. 328.4. And we get 18.12. So 18.12 is our standard deviation. Alright, so now we're going to have a new set of scores. Except this time what we're going to do is that we're going to have this per 52, they're going to drop out of the class. And to save us some time, I already calculated the changes, how this changes the sort of changing of the scores. So if you'll see, compared to the so we got this. So let me just review these new sets of data. What they do is they take out the 52. So the person who had the 52 decided the class was too hard. Sort of sounds like a familiar situation that we had, and they dropped the course. So that 52 was removed. And if we take a look, we'll see how the class has changed. So the 52 made the mean go higher. The median also went higher. The mode stayed the same, but we'll see a huge change here in the standard deviation. That 52 was making the range of scores much higher, and by taking out, made the standard deviation get much lower. So obviously the average score now increased, and the range, or the sort of variance in the scores, decreased. Now the median also increased, and we'll see the relationship between the mean and the median is an important one. So back to sort of histograms. There are three types of histograms. You could have a normal distribution, and a normal distribution looks sort of like a bell curve. And in a normal distribution, the mean equals the median, as very extremely close as possible. So the mean equals the median. In a normal distribution, about 68% of the data, or exactly 68.26% of the data, is within one standard deviation of the mean. So if you take the mean and subtract one standard deviation of it, that will cover 34% of the data. And if you add the standard deviation to the mean, that will cover another 34% of the data, for a total of 68% of the data. So in a normal distribution, 68% of the data is within one standard deviation of the mean. 95% of the data is within two standard deviations of the mean on either side, and three standard deviations from the mean. There's 99.74% of the data. So if you ever take college statistics, this sort of 68, 95, 99 rule is really important. Okay. Now, data can be, or histograms can be skewed to the right. So the skew to the right are ones where the tail end, or all the numbers are towards the left and the tail is towards the right. Data that is skewed to the right has a mean greater than the median, because there are numbers here that are pulling the mean up high, and the median is somewhere in here. Probably here looks like the median would be. But these numbers at the end make these sort of outliers, is what they call them. Sometimes we call them outliers. They pull the mean up. And then we have histograms that are skewed to the left, so the tail of the histogram is towards the left. And this is where the mean is less than the median. So here, the median would probably be around about here, but the low numbers, the low end numbers, or the extreme values, the outliers here, they pull the mean down. So if we go back to our test scores, okay, this here this is skewed, right? Because the mean does not equal the mean, and this one is also skewed. So here, the mean is lower than the median. So that 52 was making the data be skewed to the left. That 52 was an outlier, so it was towards the end of the histogram. And made the data skewed to the left. This one is slightly skewed to the right. The 98s, which are the outliers in this set of data, not as much weight as these ones, but they skew the data to the right. So now what I want you to do, and I have 50 seconds to finish this thing, otherwise the video is going to end, is I would like you to finish the paper that practices these skills. It's about elephant trunk length. In the paper, you'll see that there's a table and it tells you how many of each number there are. So if you have 20 numbers, you're going to have to type in 20 numbers. You'll see that I gave you a calculator online to calculate standard deviation, because you're going to have 80-something data points, and calculating a standard deviation with 80-something data points would take forever. So that homework is due on Wednesday. Alright, I'll see you guys.